So this is section 3.4, algebra properties used in geometry. Okay, so we're going to start with some different types of properties here. So we have three different types of properties we're going to use in these proofs and in these couple sections. Okay, so our different types of properties are defining properties, which are basically definitions, so like definition of a circle, definition of midpoint, things we've defined. Then we've also got assumed properties, which is what we call our postulates. So we've written some postulates before. And then also deduced properties, which is our theorems or things that have already been proved. Okay, so we've got definitions, postulates, and theorems we're going to be using here. Okay, so the first things we have are postulates of equality. So the first one we have is reflexive property of equality. So what reflexive is it's basically something equaling itself. Okay, so the example they give here would be A equaling A. So the same exact thing on both sides. Maybe you had 5 equals 5 or 6 equals 6. That would be reflexive property. The next one is symmetric property. So symmetric property says if A is equal to B, then B is equal to A. So basically what they did there is they just flopped the A and the B around. So they lead with the A here, and then equals are B. So if A is equal to B, then they flop it, and they lead with B this time, and then end with A. Okay, so symmetric property is basically when we take two things and flip them around. So if you had like 2 plus 3 and, or 2 plus 3 is equal to 1 plus 5, or 1 plus 4, and then we flop it around, 1 plus 4 is equal to 2 plus 3. So since both of those sides equal 5, then that would be symmetric property, just flipping the two halves around. Now transitive property is when we switch three things around. So you've got your A and your B again. So you've got A is equal to B. Then we're also going to throw a C in there. So then we're also going to say that B is equal to C. Then since if A is equal to B and B is equal to C, then we also know our original A value, whatever that is, that has to be equal to our C value. So basically that's three things being switched around, three things equaling each other. Okay? So reflexive, something equaling itself. Symmetric is when we switch two things around, and then transitive is when we switch three things around and they're all equal to each other. Okay, the next thing we've got here is postulates of equality and operation. So we've got two, so we've got addition property of equality and then multiplication property of equality. So addition property of equality is basically saying if we've got A equals B, so two sides equaling each other, then if we add the same thing to both sides, so if we add C to the A and C to the B, they're still equal to each other. Okay, so that's the addition property of equality. So if you think about your addition property being like scales, so you guys have seen the scales where it's like the balancing beams here, and they got like a little tray, and then same thing over here, you got a little tray. So if we had an A on there and a B on there, and those trays were equal to each other, so maybe both sides were like 5 pounds or something like that. If we add the same thing to both sides, so if we had a C here and a C here, say C maybe is 1 pound, if we add the same amount to both sides, those trays are still going to equal each other. Okay, so if, you know, this was 5 and this was 5, and then we add 1 to each of those, both of those sides would still be 6, so they would stay equal. So that's basically saying you can add the same thing to both sides. Now this also works for subtract. They don't list a subtraction property because subtracting is the same thing as adding a negative. So we don't really have to have a subtraction property because it's really the same as addition, just with negatives. Then the next one we've got here is multiplication. So basically it's the same exact thing where we start off with an A equaling B, so two things equal each other. Then we're going to multiply both sides by the same value. So in this case, we're going to multiply both sides by C, and it's still going to stay equal. Okay, so just the same as over here. If we had our two sides equaling each other, did the same thing to both sides, it would still be equal. And again, we don't have a division one for this because division is the same as multiplying by the reciprocal. So we don't need a division one of these technically. So we only have an addition one and a multiplication one. Okay, so the first example here, these are called proofs. So basically what a proof is we are proving or telling why or explaining why we can do math. Okay, so here we're going to take an equation and we're going to solve it out just like we learned how to do in algebra. But we also have to explain how we know that we can go from one step to the next. And we can't just say, well, we can do it because, you know, the teacher told us or the book told us. We have to actually justify or prove these with postulates, theorems, and definitions. Okay? So here it says, give the postulates of equality and operations used in solving, and then they've got the equation 24x minus 12 is equal to 60. Okay, so when we start to fill out something like this, we've got two things. We've got the given, which is the information they give us, and then what we're trying to prove. Okay, so our given in this case is going to be that equation. Okay, so that's the information we're given to start, and we're trying to prove by basically solving here. So the solving part of this is going to be our proof. So we always start with the given, and we're trying to end with that proof part. Okay, so when we fill these out here, our given is the first thing listed, so we're going to go 24x minus 12 is equal to 60. And then our justification for writing that is, well, they told us that in the problem, so we just say that's given. Probably 90% of the time, the first one is going to be always given. That's not always true, so don't just write given right away because it's not always true. But if they do tell you this information right in the problem, then we can write given as our justification. Okay? So now what we do is we solve this like we did back in algebra. So the first thing we're going to want to do here is we are going to want to get rid of the subtract 12. So if we get rid of subtracting 12, we're going to add 12 to each side, because then those are going to go away. And then I'll have 24x is equal to, and then 60 minus 12 is, or not 60 minus 12, 60 plus 12 is 72. So then here, to give my justification, basically what I do to get my justification on this side, I have to see how I went from this step to this step, and that'll give me my justification for there. So if I look there, I added the same thing to both sides. Well, we just talked about that up here with our scales, so when we add the same thing to both sides, that's the addition property of equality. So our justification or our reasoning for being able to do that step is going to be addition property of equality. Okay, and you want to make sure you write all of that out because we've also got properties of inequalities, which are slightly different. So you'll want to make sure you write that whole thing out and don't just, just do addition property because that means different things. Okay. Okay, so then we go back over here and we keep solving this. So the next thing I need to do to get the x by itself is I need to get rid of the 24, so I'm going to divide by 24 on each side. So then that's going to go away because 24 divided by 24 is 1 or 1x. So I'm just going to have x. And then if I do 72 divided by 24, I end up getting 3. Okay. So here, what I need to do is go from this step to this step, and that'll give me my justification for the third part. So if I'm dividing both sides by the same thing, well, we talked about before that dividing each side by the same thing is the same as multiplying by the reciprocal. So really here we're going to use the multiplication property of equality. So multiplication property of equality. Okay, and then sometimes the book has a weird thing here where they'll, like on this third step here, they might write like x is equal to 72 over 24 instead of actually doing the division out. So if you see something like that and then they write this last one as x equals 3. They just call it rewriting the fraction as a decimal, but I'm not really too worried about that, so I wouldn't even worry about that last one there. Okay? Okay, so we'll go to the next thing here. So we'll do another one of these, but this one involves angles. Okay, so here we've got, suppose that the measure of angle AVB is equal to the measure of CVD. Okay, so we've got two angles there and they're equal to each other, and then we're supposed to show that AVC is, or the measure of AVC is equal to the measure of BVD. Okay, so let's do some colors here because that makes it a little bit clearer for me to understand. Okay, so I've got AVB, that angle right there. I'll make that one pink. And I've also got CVD, that one there, CVD. And then they say I'm supposed to show that AVC, so the pink one and a little bit more here, is equal to measure of BVD, so that middle one and then the yellow one. Okay, so what we can do here is we can start out with what we're given. So we're given this angles here, or these angles being equal here, and we're trying to prove that the measure of these angles is also equal. So we're given this information here, and we're trying to show that end information there. Okay, so like we did before, we're going to start with the given. So we've got the given is the measure of angle AVB is equal to the measure of angle CVD. Okay, and we got that information because it was given to us in the problem. Okay, so now usually this is kind of the tricky part here, is figuring out kind of these middle steps. So let's jump to the prove part. So we know in the end we're trying to prove that the measure of those two angles is equal, so that's always going to be our last step here. The last step is always what we're trying to prove. So the measure of angle AVC is equal to the measure of angle BVD. Okay, and then we don't put prove here, we actually have to give a reasoning why that happens. The only one that we can write just a word in for that it doesn't really matter what it is going to be given. Okay, we can't just put prove for this side because we actually have to give some sort of reasoning why that actually works. Okay, so what I'm kind of thinking here is if we've got this angle here and we've got this angle here and they tell us that the pink angle and the yellow angle are equal to each other, the only difference between those two angles and these ones over here is this middle space. So I'm going to color this middle space green here. And I'm thinking if we add that middle space to both of those angles, we're going to get these angles. So let's do that here. So if we look at measure of the pink one, so measure of AVB plus the measure of angle BVC, that's going to equal the measure of the yellow one, so measure of angle CVB or CVD plus measure of angle BVC. Okay, so basically what we're doing here is we're taking the pink angle, which here we had the pink angle, here we have the pink angle, and we're adding the green angle to it. So if we took the pink and the green and added them together, then we get AVC, that full angle there. And then if we do the same thing with our yellow angle, so the CVD, that one there, which is over here, and the green angle, so that one there. So if we take the green and the yellow, that's going to give us our bigger angle here. Okay, so if I'm looking at my steps, to go from this step to this step, that's how I'm going to get my justification for the second one. So if I think about it here, I'm adding the same angle to both sides, and that's that same addition property that we had before, adding the same thing to both sides. So adding the green angle to both sides is the same addition property of equality we had before. So addition property of equality, because we're just adding the same thing to both sides. So even though it's not just a number like it was before, we're adding the same angle to both sides. Okay? So now this next one here, basically when we combine together the pink angle and the green angle, we got this angle here, AVC, which was the pink angle and the green angle together. And then the other one, BVD, was our yellow angle and our green angle put together. Okay, so basically we added the pink angle and the green angle to get that full angle, and we added the yellow angle and the green angle to get that full angle. Okay, so to get from this step to this step, what we're actually thinking here is I know that the size of the pink one and the green one added together is going to give me that full angle from AV to C, which is there. And then I know the whole measure of the green angle and the yellow angle is going to give me the same as BVD. So this one is going to be our angle addition assumption. So angle addition assumption. Which we talked about last section. So this is on page 127 if you don't remember it. So this was from the last section, and on 127, if you flip back to it, it basically says if we add two angles together, we get the bigger angle. So like the pink and the green, we added the pink and the green together to get that bigger angle with the pink and the green. Okay, so that's going to be the angle addition assumption for our explanation. Okay, so next thing here, we got some more properties. These are properties of inequalities and operations. So inequalities is basically when we have our less than and greater than sign in there. Okay, so the first properties here, we've only got the transitive property of inequality. So that's basically saying if A is less than B and B is less than C, then A is less than C. Okay, so if I put some numbers in here, so like if I say 1 is less than 2, and then for B again I put a 2 is less than 3, then I know if I use my A and my C, then 1 is less than 3. Okay, so that's transitive, so switching three things around again, this time just with inequality signs instead of equal to signs. Now this doesn't work for reflexive and symmetric, because if I did this for reflexive, where both numbers are the same and I went like 1 is less than 1, that doesn't really make sense. Okay, so it doesn't work for reflexive. Same with symmetric. This doesn't work for, because like say if I went 1 and 2, so I went 1 is less than 2, and then I tried to switch those around, 2 is less than 1, that doesn't work. Okay, so this only works for transitive, it does not work for reflexive and symmetric. It does work for addition and multiplication. So here, if we are adding the same thing to both sides, that still works out okay, because if we've got A is less than B, and then we add C to both of those sides, it's still less than. So like if we had, I don't know, 1 is less than 2 again, and then we added a value to both sides, so we did 1 plus 3 is less than, and then our B was 2, 2 plus 3, so that would be 4 is less than 5, so that still works out there. This also works with negative, or not with negatives, multiplication, where if we multiply both things by the same value, then we're also going to have less than. So like here, if we take A is less than B and we multiply it by a value that's bigger than 0, so like a positive number like 5, then A times C is going to be less than B times C. The only thing you have to be careful on this one is if you multiply by negative values or values that are less than 0, your sign is actually going to switch around, because when we multiply by negatives, the sign switches. So like if it was a positive 5 multiplied by a negative 1, that's going to multiply to be a negative 5, so we have to switch our sign around there. Okay, so just be careful on that, but you're basically multiplying the same thing by, or both sides by the same thing. Okay? Alright, so let's look at the next thing here. So the next one we've got here is postulates of equality and inequality. So we've got equation to inequality property. Okay, so they say if A and B are positive numbers and A plus B is equal to C, then C is greater than A and C is greater than B. Okay, so we'll actually talk about that down here. When we get to this one, you'll kind of see how that works. So I'll talk through that one in a second. Okay, and then the next one we have here is substitution property. So substitution property is when we replace something. So it says if A is equal to B, then A may be substituted for B in any expression. So like if A was equal to 5, then you could substitute 5 anytime you saw B. Okay, so substituting is just replacing a value with what it equals. Okay. Okay, so let's look at this here and talk about the equation to inequality property. Okay, so going back to this property here, if I assign some values, say like if I go 2 for the A, plus we'll make the B 3, and we'll make the C 2 plus 3 is 5. Okay, so what it says here is C, our 5, is going to be greater than, and it's supposed to be an A up here, and our A is 2, so 5 is greater than 2. Well, that's true. And then our C, our 5, is greater than the other one. Our B was 3. So the 5 is greater than both of those values, so the total is greater than the two parts. Okay, and that's what they say here, the whole or the total is greater than any of its parts. So we can kind of see this in a picture here. If we've got some chunks of a line, so we've got the distance from X to Y, so we'll just assign a number here, say that's 4, so we'll make that 4 there, plus our distance from Z to Y, say we make that 2, so 4 plus 2 is equal to our full distance there, which if you take 2 plus 4, that gives us 6, so the distance from X to Z is going to be 6. So what they're saying there is the distance from X to Z, which is 6, is going to be greater than the distance from X to Y, which is 4, and then also that same distance from X to Z, which was 6, is going to be greater than the distance from Z to Y, which would be 2. Okay? Because if you think about it, if these two parts went together to make the whole thing, those parts have to be smaller than what the whole thing is. So that's what they're saying here. The whole is greater than any of its parts. So the whole thing added together, 6, has to be bigger than the two things that make it up. Okay? And then the last property we have here is distributive property, which you guys have heard of before when we did algebra. So distributive property is where we're taking the A times the two things inside parentheses. So we're taking the A times the B, which gives us AB, and then the A times the C, which gives us AC, and then we're adding those two values together. Okay, so that's distributive property if that comes up in some proofs. Okay, so for your guys' assignment, you've got page 136, 2 to 16 even. And let me look here. So it looks like, hopefully, what page is it? 136. Hopefully those aren't too bad. It doesn't look like any of those you have to set up a full proof. So a full proof would be like these here. It doesn't look like any of those you have to set up anything like that. It looks like it's just asking for different properties. Number 4 on that would be really similar to this here. So when you set that up, so it says what properties did you use to find the solution, you could set it up in a T-chart like this and then put your equation on one side here. So 7x plus 17 is equal to 31. You could put that here and do the same exact thing we did here where we solved it out, and then our properties that we used for B would be kind of like this, where we're justifying how we did each of those steps. So that would be what number 4 is like. Are you doing evens? Yeah, you're doing evens, so you don't have to worry about 5. What else? it looks like the rest, they're probably just using the different properties, not where you have to like set up a chart. So you should be okay for the rest of those.